So, welcome everyone, and welcome to our last lecture on this part of this course. And today we will talk about requirements modeling and management using tools. So we will introduce two tools that you can use, uh, and that you have to also use for your RE assignment. But yes, let's get started. And let me know if you have any questions following this lecture. So today we are in the third part of the course, and stay with me uh, if you are joining, and don't leave early because I will also briefly discuss the assignment at the end. And today, as I mentioned earlier, that we will have more or less 3 hours of lecture, and we will have 2 breaks in between. So hopefully we can do that. Before starting the lecture, I just want to ask you about, so do you have any previous knowledge, or do you know or became familiar with UML modeling from other courses? Or have you worked with UML modeling before? Just let me know on the chat, yes or no. At the same time, you can also put your questions on Slack. So I will be following both the Slack and YouTube. Okay, so it seems that you already are familiar with UML model. So part of my first part of the lecture was also about UML. So I will try to go a little bit faster and focus more on the hands-on part. Yeah, that's good that you already know the UML modeling. So since you are already familiar with UML modeling, you know it's a graphical modeling language. It has many components like classes, attributes, operations, and relationships with the classes or among the classes. I think I just also wanted to know, so did anyone was able to install those two tools, like for the Eclipse plugin for OCL and the STS modeling tool that I showed in our last lecture? And as as you know, I also published a tutorial. So did you or anyone had time to follow that tutorial? If you have a problem with STS, it could be mainly due to 2 reasons. One is if you are using a Mac, you should put that STS program in your applications folder, or if you are using Windows or other machines, you have to make sure that you are using, or you have the latest Java basically. It should work from Java, I guess 7 until onwards, but it's good to have the latest version of Java. And the third option could be if the configuration is not properly done, like if you do not mention your proper path for your Java virtual machine. I will discuss a little bit later about this when we will be working with STS. but it seems that at least some of you tried and are on a good shape. And if you have any questions also, you can book your slots for tutoring, and we can discuss your problems during the tutoring sessions. So talking about UML, this was standardized and proposed by Object Management Group. So it's a group of practitioners from government organizations, from software development organizations, from academics or universities. So they revise and or update UML specification more or less every 2 years or every 3 years. But the first version of UML was proposed in 1997, so it's quite old. And as you can see, there is a new version every 1 year or every 2 year, but sometimes there is also big gaps, like the UML 2.4 and 2.5. So 2.5 came almost 6 years after. So sometimes there was a frequent update, sometimes not. And I think the current version is UML 2.5. Okay, so in UML there are many types of diagrams. You mostly work with class diagrams or sequence diagrams or use case diagrams. Of course, many different diagrams have their benefits and use. I will not. In the previous years, basically, I briefly introduced all of them, but this year I decided not to, because those are not to be part of your assignment, or at least you don't need to know all these diagrams for this course. So you can investigate by yourself and learn more about them. So these are the different types of UML diagrams. And as we know that there are mainly two types of, if I classify the UML diagrams, those are basically either about structure or about behavior. So for example, class diagram or component diagram or package diagram that tells you how the system will be structured or organized. On the other hand, we have other sets of UML diagrams like activity diagram, interaction diagram, then sequence diagram. This tells about how the system behaves or how it functions when, or how it will function when it will be in operation. So they more talk about dynamic aspect of the system, whereas class diagrams and others, they talk more about static aspect or the design aspect of the systems. So UML basics, UML a modeling language, so it's not a programming language. There is a misconception about it. Then there is a difference between model and diagram. UML, the class diagram, let's say, is a modeling language, but as we can see that there is this notion of model and diagram, and these are completely two different things at different abstraction layers. So models are more abstract, whereas diagrams have more details. You can create a model, and then you can have many instances of that model. In the same way, from one diagram you can create from one model you can create multiple diagrams. You can use those diagrams to describe model and so on. But the main difference between model and the diagram is that, let's say you have a model, and if you want to add or delete something, remove something from that model, basically it will cause all its instances to change, because you are modifying the uh, higher level abstraction of those instances. And then it's the opposite case in diagram. So in diagram, if you change something, that not necessarily mean that you are changing the model or the meta model for that diagram. So a change in diagram might not cause a change in model, but a change in model will reflect also in all the diagrams. So there are essential elements in UML class diagrams. So these are 5 essential elements. Classes that represents basically the data or data types. Associations, how these classes are related or reference to each other. Then the attributes, these are basically simple properties for those instance classes or the instances of the classes. Then the operations, these are methods or functionalities that are provided by the instances of the classes. And then there is also generalization. So there can be a common group of classes that have the same properties, or that share the same principles or attributes and so on. So we can group them or generalize them in a hierarchical manner. So I will briefly go through each of them, and I will make it quick, at least this introduction part. So how can we do the modeling? So the first step to do your modeling will be identifying a first candidate sets of classes. You might not be correct or complete at this step. You might need to reiterate, but this is the first step. So identify a set of classes or candidate classes, we say it. And then you need to start with most important classes. So if you identify 5 classes or 10 classes, not all of them might be equally important. So you identify the most important classes and find out their relationships in terms of associations or defining their attributes and so on. And then you should also work with your generalization. So try to see, out of those 5 or 10 identified classes, can you group those classes, or can you generalize some of the classes to a common group? Then once you define the associations, the attributes, and you define the generalizations, you try to define their functionalities or operations for each of the classes. And based on the operations, you need to basically define, or based on the responsibilities, you need to define each operation. So when we are talking about operations, that means what type of operation it will be, like if it's a private or public operation, or if it has any parameters and so on. So you need to define all of those. And then you need to find, or you need to try to find some design patterns or interfaces that you can develop based on this initial class diagram that you made from step 1 until step 5, because design patterns are also good solutions for common design problems, and many software systems actually apply or implement design patterns. You might not be introduced to design patterns yet, or you might be, but design patterns are interesting solutions. You can look for them. There are many design patterns for object-oriented systems, for example. So in the 6th step, you also review your entire process and find out any problems or any missing elements in your modeling. And once you are done, basically you have the first UML class diagram, let's say, that you can consider that as complete. So classes are the data types or the core elements in UML class diagrams. They might have different level of details. For example, in this case, we have a class called rectangle with no details. We have a class with two operations. We can have a class with two attributes without any operations. We can have class with both the attributes and the operations, and we can also have a class uh, that identifies the type of the operations, so not only the data type or if they are private or public elements in the classes. So for example, height and width, those are public, and get area and resize, those are private methods. So each classes have responsibilities, and when those responsibilities are translated or transformed into operations or operation name, then we should mention in our class diagram in this way. So we should have operation name, we should have parameters or parameter types, and then we should also mention the return type. So for example, in this case, you see that get area returns and value that is an integer type. So this is how a detailed operation signature should be mentioned in the class diagram. Then we also have associations and multiplicity. So associations are basically relationships between classes. So when the classes refer to each other, and there can be also multiplicity in the associations. For example, one company might have many employees, so one-to-many relationship between company and employees. One or many managers might have many administrative assistant, so each manager might have many administrative assistant, and there can be many managers also. Each company has one board of directors, then each office might have many employees, and then also in the board of director there can be 0% or up to 8%, 8% basically, and there can be many board of directors if there are if this is a large company. So as you see, these are the examples of associations and multiplicity. And the default multiplicity is basically 1-to-1 if you do not put any multiplicity. And then there is like different types of multiplicity: 1-to-1, one-to-many, many-to-one, many-to-many. So for example, this is one example of many-to-many multiplicity. So this multiplicity and associations is one of the basic class diagrams, basic operations, not operations, I would say, elements to design your class diagram or draw your class diagram. So in this case, we did not give any names to these associations or to these relations, but associations can be labeled or can be given a name. Usually, there are two types of names that we can give. So either the association name itself, or we can give a role names as our label. So when you are giving a association name, they should be a verb or verb phrase. I will show some example here. And if you do not have any association names, that means by default it has it's a has relationship. For example, in this case, one company has many employees, or one board of directors, or one company has one board of directors, and they're vice versa. So they are uh, bidirectional associations. Not any, there is no direction for the association or for the relation. So both ways are true basically. So these were examples that shows that there is no labels for the association. That means they have by default these has relationships. But then we can also name the relationships or the associations. For example, and as I mentioned, that your labels should be verb or a group of verb. So verb phrase, uh, words combined with other verbs. So many employees work for one company, and as you can see, this works for, um, it is in the middle, right? That means this applies to both employee and company. So company also works for the employee. So I mean, it gives salary, it gives various benefits, it offers uh, promotion and so on. But as you can see, some of the labels or some of the associations, they are on the either on the right side or on the left side. So in this case, uh, one or many manager is a supervisor, or has or is or act as a supervisor for many administrative assistant. In the same way, 0 or 3 to 8 person are board member of many board directors. In the same way, this office and employee, this relationships is in the middle. So this applies to both. But again, these kind of associations are not bidirectional, but we can have also unidirectional associations. I think I have examples later. But then we need to make sure that we are having a correct association, and we are also having correct multiplicity, because uh, with a wrong association or wrong multiplicity, your model might have errors or issues when you will be instantiating your models, or when you will be creating instances of your models. So, for example, if we have a class called person like this, who has a name, and we also have a class called person info, who has an address, an email, and birth date. Although theoretically it's correct, but uh, semantically, or from the uh, UML perspective, it doesn't sound right, because you can eliminate those kind of complex uh, or redundant relationships by merging them into one class. So instead of saying that one person class uh, is associated to one personal info class, you can have simply a person class with name, address, email, and birth date, and so on. So this is one way of uh, simplifying or validating your associations. And then you might have more complex associations. Um, for example, one passenger is making many bookings, and many bookings uh, has or is correspond to a specific flight. So in this case, we are basically having an intermediary class to find a relationship between passenger and specific specific flight. So in this case, this booking class also has a special name. I think I have it in the next slide maybe. So the idea here is that you should not have redundant or unnecessary associations or multiplicity, and make sure that you have multiplicity where you only need, I mean, don't introduce unnecessary multiplicity if I mean, just by chance or making some assumptions. And you should also read all your associations, especially when you have multiplicity from both the directions. So you have to make sure that a one passenger might have multiple booking, means that many bookings can be made by one passenger. So both, if you read them from the both direction, they hold, or they are still true. They should not be conflicting. And since these lines or these associations, don't have any error, as I mentioned earlier, that both directions should be hold or should be true. So make sure that you read all your associations from both sides, and they make sense, unless there is some direction in the association. And association classes. So as if you remember, so I mentioned that the relationship between passenger and the specific flight is maintained by these classes, by this class, booking class. So this booking class is basically an example of association class. How is that? So for example, there is another example. So we have this relationship between student and course section. So many student might be registered in many courses. At the same time, many course section might be registered by many students. So since this relationship is applicable to both the student and the course section, and this relationship is also in the middle of the association, that means it doesn't only correspond to students or doesn't correspond to only course section. This kind of relationships can be replaced by an independent class, and that is known as association class. And the benefit is that it makes your diagram less confusing and more explanatory. So instead of having such complex relationship, what we can do, we can have, or we can create a new class called registration, and this registration class has an attribute called grade. And this registration class basically works as an intermediary class when defining the relationship between student and course section. So basically each or all the students who will be registered in a course sections must have a grade, and it should basically pass. But then this kind of association classes, they are basically, this is same as this one. So basically one student might have many registrations and they have all their grades, and many registrations or one course basically can have also many registrations. So this is the same representation that we seen in the previous slide. And that's the concept of association classes. And usually we mentioned that the labeling of the association should be done by verb or verb phrase. But when you are creating an association class, this will not be anymore a verb or verb phrase. Rather than you should create this association class using a noun, because all your classes are by default named using a noun, right? So it should be the same rule here. And there is a tips or idea that if you have many-to-many relationships, that means there is an opportunity to replace those many-to-many relationships by a association class. And the benefit of having this association class is that it makes your implementation easy. And if you can see from this representation that many students are related to many course sections, so it's hard from these representations which courses we are talking about or which group of students we are talking about. If we break this relationship into like this here, then this relationship's basically about only one student and only one course. So now we know that which student we are talking about or which course we are talking about, and it explains the model better. Then there is also reflexive associations. So basically the idea is that a class can be associated by itself or with itself. There is two types of reflexive associations, asymmetric and symmetric. Asymmetric associations are basically when the source and the destination role are not the same. And the symmetric one is basically when the source and destination roles are same. So for example, if you think of a course, each course might have a successor course, and each course might also have a prerequisite course. So this successor course and prerequisite course, they are two different courses. That means they are asymmetrically associated. But each course, let's say we are talking about software design course. So software design course is mutually exclusive with another software design course. Let's say the software design course from the previous year and software design course from this year, they are mutually exclusive. But this software design course might have a prerequisite course, and it might also have a successor course, and those two courses are different. So that's the idea. Although they are reflective associations, in asymmetric associations, the instance model might not have or will not have the same course, but this symmetric association will have the same course. So I was talking about associations and directions, and all the directions or all the associations that we discussed, those were basically bidirectional. And by default, if there is no arrow, the associations are bidirectional. But in general, or we should have defined well, if you are planning to use unidirectional associations. And if you use unidirectional, it's easy to explain the model, or it's easy to instantiate the model. But the problem is that it basically limits the flexibility of the model. But I think having unidirectional associations is more useful and less error prone. So you should try to use unidirectional associations. And in this case, for example, one day or each day has a number of nodes. So the nodes only correspond to the day. The vice versa does not hold or is not valid. So we are talking about. So we talked about classes, we talked about associations. Now we are talking about generalizations, or how can we group a sets of classes into one group. So the idea is basically it's this generalization. It represents a relationship between the subclasses or derived classes and the superclass or the base class. So here, for example, we have a superclass account, but an account can be any types of account or many different types of account. So that can be a savings account, that can be a checking account, that can be a mortgage account or a credit card account, and so on. So this kind of generalization is known as inheritance hierarchy. So savings account inherits all the properties of an account. And since you are already familiar with UML and Java programming, you know how this inheritance works. Then there is a difference also between associations and generalizations. So associations are basically runtime thing, or whatever association information or relationships you are defining as part of your class model, class diagram, they will be reflected in your instances at runtime. But the generalization is basically more about design time or more static thing compared to association. So, and for example, you might have association defined in your class diagram or in your object diagram, but your object diagram, since this is a dynamic thing or dynamic instance of a class diagram, so this object diagram can never have any generalization. I think this I already mentioned. So then there is the aggregation. So we talked about association, we talked about generalization. There is another concept called aggregation in UML class diagram, and that is basically the whole part or part-whole relationships, usually represented using a diamond symbol. And in many cases, or in most cases, aggregations are basically one-to-many relationships. We also saw one-to-many or many-to-one association relationships, but then that association only have the meaning of has or something like that. But this kind of aggregations are basically part of or part whole relationships. For example, one vehicle might have many parts, many vehicle parts. One country might have many regions. One building might have many rooms, and so on. So in this case, vehicle, country, and building, those are aggregated or assembly part, and room, region, and vehicle, those are basically part or the building blocks, in other words. There is also another notation called interface in UML class diagram. So basically, interface describe a part of the behavior or visible behavior that can be implemented by a class or an object. Usually, those interfaces are defined using this interface notation. And for example, this is an example here. So for example, one employee is a person and an ATM is a type of machine. So this both ATM and employee can work as a cashier. So they both can withdraw or deposit money. So in this case, if we define an interface called cashier, then this employee class and this ATM class can implement this interface. And when it is implementing this interface, that means that it can implement some of its operations. Usually this interface is an abstract method, so, or abstract class. This interface class is an abstract class, so you cannot instantiate this interface class itself. You can only implement by other classes. These I already mentioned. Difference between generalization and interface. So, and do anybody? I think there was a question that I missed. Why was the color different for the last one? I don't know which color you were talking about. Okay, so I think I have probably explanation on this in the next slide. So yes, a good question. So we have a vehicle here. So one vehicle is a aggregation of many vehicle parts. One country is an aggregation of many regions, and one building is an aggregation of many rooms. So someone asked why these don't have colors and this is color or black. So the idea here is that this is another special kind of aggregation that is called composition, and I think I have one slide on that. So when you, let's say, break or destroy, not destroy, if you break this vehicle, all the vehicle parts are still there, but they are not vehicle anymore, or they are not part of that vehicle anymore. If you also, let's say, divide a country, or if it's different regions, and those different regions became the country by themselves. So the idea here is that those regions exist, but the country that we broke and made multiple countries, that country doesn't exist. Or that country doesn't exist, but those regions by themselves still exist. But on the contrary, if we have a building that is made of many rooms, if you break this building or destroy this building, you are not only losing all the rooms, but you are also losing the building itself. So that's called composition. Like when you have the whole part destroyed, the individual elements that make the whole part is also destroyed or doesn't exist anymore. So if you break a building or destroy a building, all the rooms are destroyed also. But if you break a country or a vehicle, all the parts, they are not part of this vehicle anymore, but they are also not destroyed. The regions are there, the vehicle parts are there. So that's the idea. I think I have the slides later. Okay, I think that's the slide. I think there is another question. How do we model abstract classes? Generalization with the abstract class name, generalization with the abstract class name in italics. It depends what various tools offer you graphically. So there is no specific notation for abstract classes. I don't remember particularly which tool offers what, but yes, it depends on the tools. So I was talking about composition or the strong aggregation. So if you remember this example, so this example of building and room is an example basically of composition. And composition means it's a strong aggregation. So I think I already discussed it since someone asked this question. And then another, I think one of the last concept I want to discuss is that if you have a my mouse is moving too much. So if you have a composition relationship like this, so and you have if you have an employee class, and that employee class is composed of or associated with an address class, that address has street, municipality, region, country, and postal code. You can represent this composition as this. So you have an employee class still, but you have a complex data type. Uh, and this complex data type, you can also represent basically vice versa. So it's up to you if you want to have a class with a complex element or attribute as part of this class, or you want to break down this class into two and have one employee class with that correspond to another or linked or related to another address class. So both are equally correct. But I think you got the idea of composition here. So I think this is the last part of before we will have a break, and that is about describing your UML model. You can describe it in different ways, as you know, either using a descriptive language or descriptive text or using other diagrams. But when you are using descriptive text, try to not to be repetitive, like whatever in your model, don't reflect that in your text. Try to give other perspective of the model or different views from the model. Another way of describing your UML model is to provide small notes embedded as part of your UML model. And then the third and most interesting way of describing your UML is using the constraints. So those constraints are machine readable, they are machine solvable, and they are logical statements that must need to be true in order your model or meta model to be valid. One of the very well-known language for writing or describing this kind of modeling or this kind of UML models is OCL, or Object Constraint Language, that you write on your meta model, and all your instances that you generate from that meta model should be or will be automatically checked. We will have a hands-on session in some minutes on this. So this is an example how you can describe your UML. So one is using the natural language and add some notes. Although these are helpful to understand your model, but these are not um, technically usable. Technically usable, I mean, for example, if you write OCL constraints like this, so you have a line class, for example. So each line has a start point and end point, and it also has a length. So what you can do to verify that instance of this class is correct is that you can write a condition or logical statement using OCL to verify that this start point and end point are not equal. So usually by line we mean that we have two endpoints, right? And those two endpoints should be different. So this is one simple way of writing logical constraints. Also, for example, what else? So this path class, so it can be any path that has a length, and the total length of this path should be uh, the length of the edge. So if we have an edge, uh, basically this path is also similar to line, but this path can be like zigzag and any other form. So the total length of the path is basically the total length of the edge, and that is also checked by this formula or by this OCL. So there can be many other, but I think I have some examples. So today we will use eCore, and what this eCore also help is you design your UML, you write your constraints, all the UML, and then using this eCore you can generate the corresponding Java code that will um, conform to the constraints or whatever limitations you put in your UML model by means of OCL. We will not look into the code generation part. That is basically part of the development, but we will look more on the development, not sorry, on the OCL part or the constraint part. So what is OCL? OCL basically a formal language that you can use to define your invariants. This invariance basically, I think there is a typo here, so it should be must. So this invariance should or must hold true on your instance models, and usually these invariants are defined on your meta model. And using this OCL, you can also what you can do, you can query over your instance model or over your objects in the instance model. I think there is a question on YouTube. Will the other modules look into the code generation part? No, I don't think so. Other modules will not look into the code generation part. So why we are using OCL? First of all, although we can use natural language, but this might have some ambiguity in the specification or in the description of your UML model. And since OCL is a formal language, it's a constraint defining language. It has no ambiguity in its specification, neither it has any impact on your model, meaning that it cannot change your or change the behavior of your model. It only controls the behavior of your model or checks the behavior of your model based on what you define in your model. So there are some basic OCL operators, or you are already familiar with many of the operators. So mathematical operators, logical operators, it can have strings, integers, real numbers, and so on. It can refer to the class name. It can refer to association names, attributes, and so on. So you can basically access all the members of a class or of a class diagram using these OCL operators. So it was defined by IBM many years ago. I don't remember the actual year, but the last stable version of OCL is 2.4, which was released in 2014. So wrong conceptions or misconceptions are that OCL is a programming language, so it's not. It doesn't have any logics inside it, but the evaluation of an OCL constraint or OCL expression should always be true, and it must be true. If it doesn't evaluate to true, that means your meta model has a problem, or your model definition has a problem. I think I have 2 or 3 examples, and then we are done for this part. So this is a simple example with a class called person, and this person has 3 variables or properties. Student, if the person is a student, the name of the person and the age of the person, and then a method called show details, so it will show the details of the person. In terms of associations or relationships, this person, so these are reflexive association, and as you remember, or if you remember, we described 2 reflexive association, symmetric and asymmetric. So this is a symmetric association. So a person might have a partner who is also a person, and then this is asymmetric association. So 0 or 2 persons who are parents might have 1 children, and they are known as a family. So the name of the association is family. And then since as you can see, this is also bidirectional, but this was unidirectional. So 1 children can be or can have also 0 or more parents, and all these children or parents, they are all person or the instance of this person class. So now if we want to define an OCL, how we can do that? Let's say we want to check that the name of the person does not have any special characters or has only capital A to capital Z and small a to small z letters. So what we can do, we can write an OCL constraint like this. So self means this this applies to the current object, self, and then this dot. So this dot is a navigation operator. Well, once you put dot here, it gives you all the operations, all the attributes, and other properties from this class. So basically, you can get this name variable, and then you can now work on this name variable using this method called matches, and it will check using this regular expression that if the name of the person has any special characters or not. So this is one simple example. Then there can be other examples or more complex examples. For example, we want to see if the partner of a person is himself or not. So a partner of a person cannot be himself, right? So we can check, we can check that self dot partner is not equals to self. So basically these relationships. Then we can also check if the age is greater than 0 or not. So self dot age is greater than 0. And we can also check that if the student, if the person is a student or not. That, and if the person is a student, he should be, or he or she should be of the appropriate age. So first we are checking if self dot student equals to true, and if this is equals to true, and if the age is greater than 8 or not. So if the student is, if the person is a student, that means he or she must be at least 9 years old. So these are simple checks, but then there can be more complex constraints that we can check over a instance or on an object. For example, we want to see if each child has two parents or not. How we can do that? Self dot children. So once we have the self object, we can get the children, and no matter how many children we have in our system, for all the childrens and for each child, it will verify that the number of parents for each child equals to 2. So as you can see, there is two new other operators. One is the collection navigator operators, and one is the verify operators. So this collection navigation operator is basically gives you all the children, or a set of children that you have in your system, and then this using this method for all, it will verify or it will make sure that all the children are verified or checked one by one, and then for each child it will, so by this operator, it means it's a verification operator. For each child, it will verify that the number of parents for each child equal to 2. So parents, so if you write child dot parents, that means it will give you the number of parents for a child, and then this arrow sign and size gives you basically the size of the set. So if a child has 0, 1, or 2 parents, and it will check if the number of parents equals to 2 or not. So there was a question: does OCL check this constraint during runtime, or will it apply them to the code only? So yes, if you mean by code here is the Java code, then I guess it's not. But if you are talking about code here, by code you mean the model code, then yes. So OCL checks all these constraints at runtime, and as you define, they will be automatically evaluated on your instance model, and you are defining those constraints on your meta model basically. So each of the instances that you create from your meta model should or must conform to these constraints. So the next part is the hands-on part, and basically we will work with model validation, not the code generation, and we will do it with the help of Eclipse. So it's 1 hour already. I will try to also make it quick, the hands-on. So let's take a quick break of 10 minutes, and then we come back. Now it's 14:19, so let's come back on 14:30. So 2:30 we'll start again. All right. I think we can resume. So basically, in the second part, or in the hands-on part of this OCL, I believe you already installed the OCL plugin for Eclipse, but then we will use the OCL to create a model, then basically create a meta model, and then we will create the instance of that meta model and update it with with OCL constraints, and then we will play with those constraints and see what we can do with those constraints. So for this part, basically, I will follow the same tutorial that I put on my Moodle. I guess some of you already tried to follow the tutorial, and if not, you can also follow me. But I will basically follow exactly the same tutorial that I published. So it's not new in that sense. Let me go to my Eclipse. So just before I start, I think I also forgot to mention this, that the Eclipse that you are using, it's better, or it will be less problem if you use the Eclipse modeling version, or Eclipse for so the tool that is for Eclipse modeling. So Eclipse modeling tool. I think if you use the general Eclipse, it might work, but it might not work properly. And if it doesn't, then use this Eclipse modeling tool to avoid any problems. And then basically you need to install this OCL. So help install new software, OCL. Sorry. Help install new software. So this is the new, this is the website that I want to use, and then you should have a modeling from some modeling, and then you will find that if you just type OCL, you will find that I already installed this OCL examples and editors SDK. So this one you need to install, and then it should work well. So once you install it in the Eclipse modeling tool, what you need to do is basically, as a first step, you should create a new project. Basically, you go for new project, and then under Eclipse modeling framework, empty EMF project. Next, in the tutorial, I think I was using a library example, so you can use the same example or same name just to avoid any errors. So I just created the project, empty EMF project. I think my machine is a little bit slow. In creating the project. My aim is to finish this part of the hands-on in 30 minutes. Then we can have another break, and then we can go for the STS part. Okay, it's taking longer than expected. That's unusual. Okay, finally. So if you have any, okay, I think there was a comments on YouTube. You do not have empty EMF project. Uh, you should go to others. Okay, I mean, you can follow my lecture now if you have problems, but then uh, after the lecture, follow the PDF that I published on my Moodle, and that is a detailed tutorial, so it should not be a problem. But as I said, either you need to download the proper Eclipse modeling version and then try to do this project. So what you will do, you will go in the, I think, I don't know why I have already this model. Let me see if the model is empty. Yeah, I think that was from the previous example. So for the sake of tutorial, I'm just deleting everything. So I will create a new model now. So right click on the model folder and then new and others. Then in the OCL, you should have OCL in ecore file. Then you also give it a name. So let's say library and finish. So it will create a model with some example code. So we will replace this code basically with our library example. I'm just taking the example code from my tutorial. So I'm just removing this code and replacing it with my library example from my tutorial and save it. So as you can see, I do not have any errors in my model. And the next step will be, so although I have this, okay, editor. So source code of my model, I do not have any visualization of the model. So what I will do, I will create a visualization first. So initialize echo diagram. It can have the same name. And then entities in a class diagram. Finish. And then it should have a class diagram. So if you just double click it, so as you can see, we have this class diagram with, let me see if I can zoom it. Maybe not. Where's the zoom? Here. So as you can see, we have this class diagram with a class called book, with a class called loan, and with a class called member. I'm just making it so that it's easy to read. Okay. So the loan has a loan debt. The book has a book name and number of copies, how many copies the book has. and the member also have a member name, and library has a library name. So I just save this UML diagram, and now, so this is not, sorry, this is not the diagram, this is the meta model. So now our aim is to instantiate our meta model and create a instance of that meta model. So we open our meta model using the eCode editor, and then we create. So we select this library class because we are creating an instance of this class, and then right click on it, create dynamic instance. It will create an XML file. So this XML file is basically the instance of our meta model. So if you finish, you will see that we have a model, meta model, and we have an instance of that model. We can only open our model using self-reflective eCode model editor. You can see we have a class, or not class here, it's an object basically. So library object, we can, let's say, give it a name called library, save it. You can also populate this model instance using new elements. So if I want to populate, I right click on the model, new child. I can add one loan. Let me see how many loans I want to create. So I can also want 2 books, and I can also have 3 members. 1 member, then another member, then new child, another member. So for the sake of population, I just give them names. So member 1, then the second member is member 2, third member member 3, and then book 1. So the first book is book 1, and it has 1 copy. Then the second book, let's say 2 copies, and it's book 2, and the loan is empty, as you can see. So for now, we can say, for example, the book 2. So book 2 is loaned by member 3. No, sorry, book 2, it has to be saved, and then the date. What is the date today? So it's 2022 February 1st. So it was borrowed today by member 3. So we have basically populated our model using new books, new loans, and new members. And if we at this time validate our model, so it says model is valid. That means whatever information I provided in the model, they are correct. Although I did not make any changes to our meta model, neither to our instance model. And now it's time to, so we saw that our model is valid, right? So now we want to do something so that our models should not remain valid, but it will remain valid, and that's the problem. So what we will do, we take this loan and create two more identical loans. So as you can see, this loan, all this loan has book 2 by only one member, book member 3. And that is the problem, right? Because if we save this instance, even if we validate, the model says is valid, but it should not, because although the loans said all these 3 loans are for book 2, but for book 2 we have only 2 copies. So there should be maximum 2 copies, not 1. So how come that our model says that our model is still valid? And that's basically where the ECOR, not the ECOR, the OCL comes in handy. So it will introduce new constraint in your meta model so that your instance models conform to those constraints, and they are checked when you are creating instances of your meta model. So we close this instance model, because if you keep your instance model open while you are changing to your meta model, you might have problems. So what we will do, we will introduce a variant for books, and the variant says like this. So the name of the variant is insufficient books, and what it checks that how many loans we have for this book. So it select all the books for this current object, so for this current book, and get the size, basically how many books we have, and then it's checking that the number of copies, it should be either greater or equal than these books that are in the loans. So in other words, we should not exceed our number of copies for the books that we are giving the loans, or we cannot, basically. So now with this new invariant or new OCL constraint, if we close the meta model and open the instance model, you can still see that our instance model is not validated, or it's showing valid because we haven't checked with our new meta model with OCL. So if we validate it, you see there are problems that are identified through our constraints. So it says the sufficient copies constraint is violated on book 2. That means for book 2 we had 2 copies only, but we gave 3 loans of the book, so it's not possible in practice. So our instance model have a problem, right? And what we can do, we can change one of the loan. So let's say we change this loan to book 1, and yes, then now we have 1 loan for book 1 and 1 and 2 loan for book 2. And if we save this new modifications in our instance model, and this time if we validate, you see that our model instance is now good, and there is no loan that crossed the limit of the number of books. So I think that's clear, right? Until this point. Okay, there was a question about STS. I think STS will work with Java 17. Then there is another question: is model part an extension? I probably did not understand well what you wanted to say. Die. Okay. Let me continue. So next, at this point, our model is valid because we identified what was the problem. Another thing that we can our this OCL provides is you can interact with your instance model, or even you can make queries to your OCL models. For example, we need to, I think, open a console. So console, and then we need to add or open interactive Xtext OCL. So for this, basically, you need to first select the model instance and on which you need to make your queries, or on which you need to you want to like investigate. So in this case, I selected library, and then I opened the console, and from this menu I selected interactive Xtext. So it has two parts. So the bottom part is for the input, and the upper part is for output. So for example, I can see books in my library model. So I had 2 books. Then I can see also the members of my library. So I had 3 members. I can also see what are the loans I had. So I had 3 loans in my library model instance, and I can also see which books have how many loans. I think in the tutorial that you had, there was a little problem, but this problem was corrected in the slides. So I will update maybe a new version of the slide on my Moodle. So I want to see for each book how many loans I have. So for that one, I need to select the book class element here, and then the problem was basically it should be self.copies. So I selected book 1, and then it's checking that if the book was not loaned more than the copy we had, so it's true. And then if I copy the same command for book 2, it will also say that true, because it was not loaned more than the copies that we had. But before making changes to our instance model, like I changed the loan 1, right? So if I were running this command, it would make a false or error. So these are ways that you can analyze your instance model, or you can query your instance model using this console. But there are also ways in your in Ecor, where you can write helper functions or operation helper operations. And what this helper function or feature does is allow you to create customized function. So here you created an invariant. So that's one use of OCL. But OCL also supports creating these helper functions or helper features. And what that does is basically when you load your instance model, it checks also against those helper functions, or if you want to evaluate those helper functions from the console, you can evaluate them also. So I'm not writing myself the new code. I just want to basically take the code from my tutorial. So what I will do, I will take the code that I already have in my tutorial and put it here as a helper function. And what it does, for example, here I'm just making some alignment and then I'm explaining. No. So as you can see, here is a new variable or property that I created that is derived and volatile. So derived and volatile means it will be derived every time I load the instance model, and the volatile means it doesn't store our calculated values. Basically, every time I close an instance model, the value is lost. So what it does, so we are creating this new variable, and this variable is basically for a current book, how many loans I have under this book, it will find. And not only that, also, is it possible to make a new loan for that book? So this available method, so it will it will calculate this loans value and checks if the loans value is less than the number of copies of this book or not. So if it's less than number of copies, that means this book is available to make a new loan. So this is one example. So as you can see, this is a derivation. That means this value is being derived at runtime or at loading time. And then this value of loans is also volatile, meaning that when we close the instance model, this value will be lost. So how can we use this helper function or helper operations? We can also use this in our in the console. So let's say we close this meta model and we open this instance again. As you can see, if I validate the model, our model is still valid. And also for book one, we want to check if if I can take a loan of this book or not. So what I will do, I will basically write that helper function available. So this helper function we wrote in the meta model, and that means that it's false and we cannot borrow book one anymore. And it's the Same for book 2, because book 1 had 1 copy and book 2 had 2 copies, and both of them are already reserved. And if we look at the properties also, you can see that now we have a new property for the books called loans. So it shows what are those loans for this book. So for book 1 we have, okay, it did not update. I think for book, okay, for book 1 it did not update, but for book 2 it updated. Let me see again. I'm just evaluating. Okay, false, and then it's book 2 is also false. So now if we go to library, okay, it seems these values are not updated, but yeah, they should be updated automatically. And one thing we can also do, we can further, so now I closed the library instance model. That means all my values are gone. So what we can do further, open this editor, we can set a condition that one member cannot have multiple copies of the book, of one book, and also one member can have maximum two loans. So that is also not checked in our instance model. Sorry, in our I mean, that was not specified in our meta model, and also was not checked in our instance model. So for that one, what we can do, so we have this created, we created this property before, and then we wrote this operation to see if it's possible to book. So now what we will do, we will create another property now, and another invariant that will check. Okay, I'm just taking my code from my tutorial. So basically, it will collect all the loans for a book, and then the invariant is for each book there can be maximum 2 loans, and also another invariant that says the same member cannot have 2 loans of the same book. That these two are checked using these 2 invariants. And now if we open our model instance, so we updated our meta model. If we open our instance, and it was valid before, but now if we validate it, we see that, so this unique loan constraint is violated on book 2. That means member 2 and 3, no, loan 1 and, sorry, loan 2 and loan 3, they are both by member 3, right? And they are also both for book 2. So that was the condition basically violated, that the same member reserved 2 copies of the same book. So this can be also solved, of course. Maybe, let's say, in the loan or in the second loan, we can simply change the member, and if we save it and now validate our model, the book 2 is still I think book 2, okay, book 1, book 2, book. So book 2 is reserved by member 2 and member 3. But what we can do also, increase the number of copy of the book. Hopefully it will solve the problem. No, not yet. It's because this loan 2 and loan 3, they are still under book 2, but different members. But okay, it should not have a problem, but I don't know why it's having a problem. Maybe one thing we can do is also create a new book. That is, no, name is book 3, copies, 3 copies, and the loan is not there. So if we give member 3 of the book 3, then I think it will validate. Yeah, so now this uniqueness constraint is resolved. Basically, book 2 was booked by loan 2 and loan 3 both, but now we added a new book in the library, and we modified the loan 3 to the book 3 and loan 2 to the book 2. So this way, yeah, you can play with your instance model. You can work on your meta model by adding new invariants, new helper functions or helper operations. And also for your assignment, you do something like this, but on your own requirements, or on the system that you will be provided for the assignment. But once you are done with your model validation, you have to make sure that your instance model is being validated. If it's not validated, you will lose your points. So once you are done with your initialization, with your meta model, and with your instantiation, what you will do, basically, you will export this library, this project, as a zip file, and then so just export it as an archive file, and then you will upload this to MyMoodle. I think many students make this mistake. They only upload this folder, model folder, instead of the whole project. If you upload only this model, export only this model project, model folder, then your project will not be executable, and you will also fail in the assignment, basically. So make sure that you export the full project as a zip, and then submit this zip. Make sure, because I will also check your project individually and run or try to run them. So both the meta model and also the instance model. So any questions so far? There was a question, is that will we use this tool and STL tool extensively for the assignment, or will it be at the level you are showing us now? Yeah, it should be at the level I'm showing it now. It's not like extensive use. You just pick one of the requirements that you will identify for a given system or given problem, and then you show the modeling and show the use of OCL on that requirements. So this requirement, for example, was for a library system, and just on the loan or providing loans to the members. So this can be one requirement. Is there any key combination to format the code or just manually? I do not remember, but there should be some key combination to. I mean, you can also do it manually, so it's not a big deal. So I think we are done with this OCL part. I don't want to also go beyond 4 o'clock. So in the now we will have a quick break, another break, and then we will come back with the STS. So see you at 15:15. So in 5 minutes. So it's like 5 minutes, not 10 minutes. Okay, so maybe we can resume. And yes, welcome to this last part of the lecture, which is about STS. Let me share the full screen. Yes. So we will also introduce another tool that you will be using for your assignment. But before that, I would like to okay. So there was some comment on OCL on the YouTube, so I was just reading at that. So before going to this STS tool, I just wanted to introduce some of the theory behind it. I will quickly. No, I don't. I do not have any idea on IntelliJ. I haven't used uh, IntelliJ basically personally for a while. So I mostly use Eclipse. I'm also not sure how stable this IntelliJ platform is for plant UML integration. So as long as you are able to write some constraint on your meta model and validate them on your model instances, it doesn't matter which framework or which platform you are using. So OCL is just one of them. So yes, coming back to this STS, so socio-technical systems, and that in today's world, basically all our systems that we are using, including smart homes, commercial websites, e-health systems, all these things are basically examples of socio-technical systems that involves social aspect like human and organizations, as well as technical aspect. So, and in the socio-technical systems, the main thing is basically the interaction between these components, and this social part and the technical part interacts to aim, or not to aim, to achieve some objectives or goals. And this STS tool basically allow you to uh, analyze your requirements in terms of goals or goal modeling. You will see it's fun. So this is an example of STS. So let's say a visiting researcher wants to give a lecture at LNU, and he wants to travel. He needs to find a cheap travels. So this cheap travel INC help him to find his flight. He also needs a hotel, so he also finds a hotel from the website, from another website, let's say, or maybe these are all part of the same system. Then he needs to pay for his ticket and so on. So all these different components in these socio-technical systems might also have other social dependencies. For example, the hotel might have uh, other services that it needs to run its operations. Of course, there are many uh, flight providers, or there are many agencies that book flights. They may work with other services to fulfill their operations and so on. So this is this is just one simple example of a socio-technical system. It can be many complex, and it has many aspects, including security aspects. We will focus mainly on security, basically, or security requirements for this part. So in the socio-technical modeling language like STS, it's actor and goal oriented. requirements modeling. So it has actors, and actors have goals. And then there is interactions among the actors. I will try to go a little bit quicker on this theoretical part because I want to focus more on the practical part. You need to know also the theoretical part, but I think if you just look at the slides later, it should be clear. There is not much complicated thing here. So modeling. There are three different types of modeling or modeling views in this tool or in STS. One is the social view, and the other one is information view and authorization view. Also, for your assignment, these three views are important. Social view represents basically what are the goals or how the actors are interacting with each other. So it's more about interaction view of the modeling. Then information view, it's basically what information they share or send across to achieve their goals or objectives. And then there is also authorization view. So it's basically between actors or between roles, what authorization they provide or allow on certain information or on certain document or on certain goals and so on. So I will basically reflect these three aspects during my hands-on session. And in the social view, we have two different representation. One is the goal delegation. That means, let's say, as an actor or as a role, I have one goal that I want to achieve, and that goal can be also a requirement. And then I might not be able to achieve that goal myself, so I delegate my goal to another actor or another role. And also, to achieve that goal or to achieve some other goals, I might transfer a document or information. So in the social view, we have goal delegation, and we have a document transmission, basically, not transformation. But then we also have security needs that we need to mention in the social view. So these security needs are basically the starting point to generate your security requirements. And the goal of this part of the course, or this STS tool, is basically to come up with a set of security requirements or requirements that are only related to security. So this is the meta model of the of a social view. I will not go into the detail. As you can see, we have actors, we have goals, we have delegation, we have document transmission, we have events. So those events are basically threads, and so on. Then there are many different types of security needs. I will not also go into detail for all of them, but I will briefly show you the list of 25 security needs that are possible to specify and model in STS. So 11 security needs that are about or related to delegated goals, so that are basically about goals. I did not list all of them, but for example, one of the very common security needs is authentication. So for the person who is delegating a goal, he or she needs to make sure that the guy he's delegating the goal is authenticated or secured or at least verified, and so on. Then there is also, for example, availability. So the guy or the delegator who is delegating a goal need to make sure that the delegatee, or who is being delegated the goal, is available for some certain percentage to meet their objective or the goal. So there, in this list, in this way, there are 9 more, but I don't want to list all of them. But one of the interesting security needs is, for example, non-repudiation or non-rep, the first one, where if I specify these security needs for a certain goal, that means that the delegatee cannot deny or reject or challenge this goal, or to accept this delegation, basically. Then there are 4 other security needs related to documents only. So document availability, document integrity, confidentiality and authentication, and all these things. You can basically specify these security needs at the document level. There are 6 different types, 6 different types of security needs for the information. So these are also similar to document, but security needs for the information is more fine-grained. For example, you cannot read an information unless you are allowed to. You cannot modify information. You cannot disclose information, and so on. And then there is also 4 types of security needs that are about authorization, that we will look in the authorization view later during our hands-on. So this is the high-level view of doing the modeling in STS. So basically, you have requirements. Let's say it can be any types of requirement, not only security requirement. Then for that requirement, you will so basically for each requirement, you will have a social view, you will have an information view, you will have a authorization view. Together, they are known as operational view for each requirement. And from this operational view, you derive security requirements, and basically this is derived as a PDF or as a as any other document, but you will be deriving as a PDF. And this is the detailed view of what are the various steps. So as part of the phase 1, you will identify stakeholders, and stakeholders here are meaning that the actors or various roles. So what are their possible security needs, or what are their interactions? So you have to think about from the requirements perspective. So for each requirement, what are the stakeholders, and what are the interactions between those stakeholders? Then you model the information view. So that was the social view, and then you have the information view. So what information it generates, what information it produces, what information it needs, basically by the actors to reach their goals or objectives. And then the authorization view is basically a authorization on the interaction between the stakeholders or actors. And then once you have the social view, information view, and authorization view, you do some analysis. And this analysis is also important for your assignment, because without this analysis, your report will be incomplete, and your project will be also considered incomplete. So what those automated analysis, you have to check the well-formedness analysis, that your model is well-formed. You have to do the security analysis, because if you do not do this security analysis, your requirements document will not have any security requirements, or your sets of requirements will be empty. And then risk analysis. Since I will show some examples later. Since we will introduce some risk or some events as part of our modeling, you have to do also this risk analysis. And finally, derive the security requirements after performing these 3 steps. So now I will briefly go through those various concepts in STS. So basically these are different notations in other words, and you will see when you will be working with this tool. So a round circle with a line is called agent. A round circle with another round line is role. So an agent can play a role, or other words, multiple agents can play a single role, but not the vice versa. And then, for example, Anna plays a role of secretary. So Anna is here is the agent, and the secretary is the role. So there is this goal box. So this green box, this famous green box, it's a goal, and it can be an objective, it can be a requirement, anything. And then when you put a goal inside the scope of a role or an agent, that means this goal belongs to this agent or role, or this role or agent need to fulfill this goal, in other words. Goal decomposition, we can decompose goals. For example, if we want to achieve goal 1, you must achieve first goal 2 and 3, or in other words, if you achieve goal 2 and 3, you will be achieving goal 1. Or there can be, so this is and decomposition. There can be also or decomposition. That means if you either fulfill goal 2 or goal 3, your goal 1 will be fulfilled. So in this case, you can fulfill either one of them, but in this case, you need to fulfill both of them. So document and information. So document is identified using a gray box with solid line, whereas information is also a gray box but with dashed line. So a document can be any document, but information can be like a small piece of information that is part of a document. Oh, STS-ML. STS-ML is a modeling language, yes. So scope and position, I already mentioned. So this goal, if it's under the boundary of an role, that means this goal need to be fulfilled by this role. And also same for document. So if this document is under this or within this boundary, that means this document belong to this role or agent, or this role or agent is the owner of this document. So we can also specify the ownership of information. So this agent owns this information. We can transmit documents from between roles or between agents. So this role, for example, is transmitting this document to this agent. I think I will show these examples later. Document authentication. So in this case, there was no authentication required, but in this case, there is a security need, as you can see, that when role 1 is sending document 1 to role 2, that means the role 2 need to be authenticated user in order to receive this document, but also role 1 needs to be authorized in order to send this document to R2. So it should be both way considered. Tangible information. So as I mentioned, information is any information is a small piece of data from a document. So whether information is correct or not, that is tangible by a document, or checked by a document, or measured by a document. Part of relation. So basically a information can be part of a document, or a sub information can be part of information, or a sub document can be part of a document. These are simple concepts. Goal document relationships. So there can be different types of relationships. So in order to fulfill this goal, we might need to read this document, or when this goal is fulfilled, this might produce this document, or while fulfilling this goal, this might modify this document. So these are different relationships between goal and document. Goal delegation. So we previously saw about document transformation. So here, this role is transmitting this document to this agent. But in terms of goal, when we write like this, that means this role is delegating this goal to this agent. So this is one of the basic concepts in STS. That means this goal should be fulfilled by this role, but then this role is not able to fulfill this goal, and in order to be fulfilled, he is basically delegating this goal to the another agent or another role. So goal delegation is a primary concept in STS, but there can be different types of goal delegation. So for example, no delegation. The delegatee cannot further delegate the goal. So if role 1 is delegating a goal to agent 1, and if it's specify this security needs, so this is also kind of security needs, then it means that this goal cannot be further delegated to other. So agent 1 cannot further delegate this goal to other agents. It has to be fulfilled. It has to fulfill this goal. And for example, this is non-delegation. Then there is, for example, non-repudiation. So when role 2 is delegating goal 2 to agent 2, and if it's specify non-repudiation as a security needs, that means agent 2 cannot reject or challenge this request. He must work on this goal, and so on. So there are different types of delegation of goals, but as you can see, it depends also on the security needs. So authentication, availability, trustworthiness, redundancy, and so on. So there is two more concepts. The first one is separation of duties. So separation of duty can be at the role level or at the goal level. So when at the role level, the separation of duty means that this role cannot be shared or played by a single person or single agent. And when it's separation of duties for goals, that means these two goals cannot be achieved at the same time, or in other words, an agent or actor is not allowed to achieve both. So she or he needs to pick up only one. And then the opposite idea is a combination of duties. So in the same way, the combination of duties are at the role level and the goal level. So when you have combination of duties between roles, that means an agent can play both the roles. So in this case, let's say Anna can play the role of program coordinator and the secretary at the same time. And when there is a goals between, so when there is combination of duties between goals, that means an actor can achieve either one or both of them. So it's the opposite of separation of duties. Events. So that is another concept. So events can be any threat that is posing towards your goal or towards your document. Let's say we have a thread called here event 1. That is a thread to goal. That means when we want to achieve this goal, we are facing this thread. And in the same way, we have a document. When we created this document might have another thread. So this kind of risk analysis is also part of your STS modeling. So basically what you will do this threat propagation or risk propagation. So since this goal is has a risk, you will do this risk analysis. What are the other agents or other goals that will be impacted by this event or by this risk or threat? Authorization. I was talking about this authorization concept that I will also show in the hands-on session. So an agent can authorize another agent to work on a goal, and that goal might need some information. But in order to work on that goal, the delegatee might, for example, only read and transmit this information. He cannot, this delegatee cannot modify or produce this information. So that's the concept of authorization. And then different information or different goal might have different authorization based on what is being authorized. So this will be also part of your authorization view, or you will need to work on this view, authorization thing. So I think that was quick and the introduction part, and that was also good so that I can spend a little bit more time on the tool. So we have a scenario here. An international student needs an official document from the program coordinator, and he wants to submit this document to the immigration officer to renew or extend his study permit. So this can be one requirement. The requirement is that the students need to produce a official document in order to submit to the immigration officer. So to fulfill this requirement, we have four involved stakeholders or actors. So the student, program coordinator, secretary, and data manager. So the question is how we can model this requirement and how we can come up with a set of security requirements in this case. Let's start. If you want to follow me, you are welcome to follow. Else you can just watch and do in your own time. So let's say I'm creating just an STS project. Okay, before starting this STS project, I just wanted to show something. So for those who have problems with the installation, you might have problems due to the fact that, let me see. No, I just wanted to show my configuration for the STS. So if I go to applications, okay. So first of all, you need to, if you are a Mac user, you need to put your STS inside your application folder. And if I go to the installation location, you can see there is a file called info plist. Yes. So in this info plist file, usually you will find that this is so this is commented out. So the path to your Java virtual machine, this is commented out. Uh, if it's commented out, that means STS will try to find out automatically your Java virtual machine, and sometimes it doesn't find. In that case, if you know your specific Java virtual, so Java path, you should basically take one of those and put the location of your Java home. So in this case, I put my Java location, and I also had this similar problem. Then I solved it using this one. So for those who are using Mac, try to solve this problem in this way if you have a problem opening up the STS. So I created a new STS project. Now I will create a new STS diagram. This can be the same name. And as I mentioned, so this is the requirement. So we want to model a requirement that is about a student asking for a letter for immigration office. Let me see if I can make it bigger. I hope. No, here is the, probably it's bigger enough. So we have first a role. I'm just want to make sure. Okay, before going into the detail of the modeling, a little bit introduction on the tool. So on the right, you have the palette where you have different notations. So different relationships, different dependencies, different symbols. And then on the bottom, you have social view. So now I'm in the social view. You have the information view, where you will have all the informations that you are putting in the social view. And then you also have the authorization view. So you need to complete these three, all of them. If you are incomplete with one of them, your project will be also considered incomplete. And then I have some other tabs that I will come after. So I had this role that was this properties name. I think I will call it student. So I have this role called student, but I don't see the no social view. Okay, so now I see the boundaries. Okay, and this student has a goal for himself. That is, he need to write a letter. Need to not write. He need to have a letter for immigration office, right? But then students cannot have this letter by himself or by herself. What he needs is to go to this program coordinator. I'm just writing in short. And what he will do, he will delegate this goal to the program coordinator. And basically, we have a link called delegation. So you simply drag from this goal to this agent here. And as you can see, this goal has been delegated from the student to the program coordinator. And the program coordinator has a delegated goal now in her scope, and it has a different color. And program coordinator needs to fulfill this, but she can fulfill this by fulfilling other goals. So she can fulfill this. So in order to fulfill this, she needs to get student record. Then she also needs to write the document, right? And then she also needs to sign the document. And these three goals should be achieved using a, no, I think I have the other way. So these three goals must be fulfilled using a and decomposition. That means in order to fulfill this goal, the program coordinator must fulfill these three. I will not go into the detail, but as an outcome of this goal, what the program coordinator will have? Program coordinator will have a document, right? That is signed letter. And basically, I'm taking, I don't know if you can read, I'm just making it bigger a little bit. So this goal will produce this letter basically. So this is how it looks. But in order to get the student record, for example, the program coordinator needs to talk to the secretary, right? And then the program coordinator will delegate this goal, get student record, to this secretary. And now secretary has a new goal called program get student record. But to get student record, secretary needs to fulfill, let's say, two other goals: get student personal data, and then another goal is to get financial data for the student, to see if the student paid all the tuition fees or not. So this is also a end goal. But to get the student data, secretary might need to talk to a data manager. So we have a data manager, and basically the secretary is delegating this goal to data manager. And when the data manager will will fulfill this goal, it will basically produce a file called personal data file. It can be any name. So basically, this will produce this, and then this personal data file will be transmitted to the secretary, right? So once it's generated, it's transmitted to secretary. So secretary now has also this personal data file. And what else? I mean, we can extend or make it more complex in many other ways, but maybe what I can do, I can stop here and see how it looks on our information view. Noise. Okay, it's not yet updated. Save. What's okay? It was probably in the top. So I'm just organizing a little bit. Okay, so if we go to the information view, we can see what information we have and who are those actors that own this information or document or file. Then we also have authorization view, but we will come to that later. But one thing, so in this social view, we identified the goals, we identified the delegated goals, and then the interactions between the actors. What is still missing is the security needs. And for example, for this goal, have a letter for immigration office that was delegated by student to the program coordinator. It might have some security needs. And what are those? Non-repudiation. So that means the program coordinator cannot deny this to give this letter. So we can open up and close these security needs. And then there can be other security needs. For example, the authentication for the delegator. So the students might be or should be authorized to send this letter to send this request to program coordinator. Then get student record. So program coordinator have this goal delegated to secretary. So maybe the secretary needs to be available at least 80% to get this goal achieved in order to get the letter by the students. Then there is personal data. For example, the data manager that is transferring to secretary. So it might have some security needs, that is sender integrity. That means it should be also the data manager should be also authenticated, or the proper person to send. Then it might be confidential information. So the receiver should, let's say, keep this personal data confidential. In the same way, for example, the signed letter. Okay, it doesn't show any security there. Then what else? So in this way, basically, you can define as many as security needs as you want, but appropriate ones, not the randomly whatever you want to define. So we defined 5 security requirements, and now you should have, okay, it's not there because the authorization view seems to be incomplete. Okay, the signed letter. Let me see. This personal data should be part of this signed letter. Then personal data, let me see if it's, no, it's not owned by okay, I can maybe add some information. So let's say there is some information called student ID or student ID. So this student ID is tangible by personal file, personal data file, and this should be owned. No, it's not owned. I mean, there can be other information also. And there can be also information like program coordinator contact info. That will be also part of, no, it's not becoming part of the, but it can be also part of or tangible by this signed letter. Okay, there is still no authorization between the student and the other actors. Okay, why? Sometimes it's okay. Now I can see it. And what else? Yeah, I cannot think of any other concepts that I want to introduce. Okay. Maybe you cannot read. Okay. No, I just want to, I mean, I'm done mostly with the modeling part and also on the information view part. But what I was looking at how I can introduce you to the authorization view, because it looks like there is no authorization yet that appears in the authorization view. It should automatically appears. Let me then do a temporary one. Student, and then let's say, okay, now it's showing. I don't know why it was not showing before. Maybe sometimes the it's like it doesn't pop out and shows a little bit late. So okay, maybe it was about zooming thing. So just 30%. Yeah, so what I wanted to show, so we have in the authorization view, so we are done with the social view, with the information view, and now in the authorization view, since there is many delegations, right, between student and program coordinator, and between program coordinator and secretary, and so on, and so between secretary and data manager. So in the authorization view, we want to authorize these interactions. So for example, between student and program coordinator, there is an authorization link. So student and program coordinator, and then you double click on it. Okay, there is only information, but student is not the owner. So what we can do, we cannot pass any information to the program coordinator. So you see that there is two boxes. One is for the information and one is for the goal. So probably we can only pass the goal, that is have a letter for immigration office. Add it. Okay, it doesn't add. Okay, now it added. And since if I double click on the information side, it says it has two information, but student is not the owner of this information. So he is not allowed to basically send this information. But even if the student send this information, the program coordinator can read only, no, okay, double click, read and transmit this information. Probably, okay, yeah. So there can be three different modes for in the authorization view. So one is the allowed button. So when you double click, it's a red green tick, when you do it 2 more times, it's a red cross, and then when you do 1 more time, it's empty. So in this case, I'm saying that the program coordinator are allowed to read this student ID. She is not allowed to modify this. She is not allowed to produce any student ID. So also this cross, and she is allowed to transmit this student ID in order to achieve this goal. And in this way, basically, you can create other authorizations. So for example, between secretary and data manager. So secretary also doesn't have, is not the owner of this information. So he should not basically deal with this information. So rather, for the goal, that is the goal, the secretary is delegating to the but since there is no information, maybe we can pass the student ID as an information. Student ID. So then the data manager can maybe also read, and he cannot transmit, he cannot produce, he cannot modify this data. And in this way, basically, you can define different authorizations. But there was a question: why don't we give the owner of the student ID to student in the information? So it's not. Okay. So someone is suggesting that in the information view, where is student ID? I think we cannot create a ownership by the of the information directly. Rather, we need to create. Okay, yeah, I think it should be the other way. So student ID is not owned by student, but student own the student ID. Yeah, you are right, Alia. So we can, yeah. Now I think we should not have those. This is always this problem, rendering problem. So I think now we should not have this red anymore because the student ID is now owned by the student. So if I remove all, so if I want to add now a student ID, it's not red anymore. I think there is some rendering problem. So on my right, nothing is shown. So now, yeah, you are right, Alia. Thank you. So what we could do is make the ownership of this student ID by the student, and then student can allow or deny sharing this information to other actors. Yes, you are right. So this is the basic modeling. So the modeling parts is done. So we added authorization, we added security needs. These are the most two important part of this modeling. And now we need to do some analysis. First of all is the well-formedness. So if you see the C button on the top, it should check that your model is well-formed or not. There is some orange, and luckily there is no red. So my model is well-formed. You need to make sure that you also run this analysis. I think one thing is missing is the event. So we can maybe add an event. Let's say these are risks basically. So deadline. So we might have a deadline. So this signed letter might have a deadline. So that's a risk or threat or event. Then there can be other risk. For example, server down can be another risk, right? So this can threaten this document or this personal data file. So there can be others, of course. So once we did, so this part was missing in my previous modeling session. So once we run the completeness check, then the next phase is to do the security analysis. I think, yeah, the next button is the security analysis. And as you can see, there is some security violations. You don't not necessarily to solve all those, but it's good to solve those violations. So as you can see, I have some green and no, many green and some red. So I did the security analysis, but then I also need to do the risk analysis. So the third button. So now if I run the risk analysis, I will also get more security requirements, but you can also do here propagate threat. So if I do the propagation of this threat, what are the goals or documents that are affected by this threat? So similarly for same for this one, as you can see, these are the different boxes in red that are affected by these threats. So I did the a completeness check or for well-formed check. I did the security analysis. I did the threat analysis. So on this this three on the top left, and then if you go to the security requirements, I think my analysis results did not pass because there was some red, but make sure you do not have any red. But I generated these security requirements. I don't know how many, maybe 10, 12. So now you have everything set, and the final step for this will be, I think you have to export. Let me see. Export, but now I think here is some also. Okay, you can basically export in many different format this security, but I wanted to export the whole report. Okay, so I think so if you export from here, it will export in the XMI or in the XML format, but only the security requirements. But I want to export the whole requirements document, including the models. So including the social view, including the information view, including the authorization view. And then there is a button on the top. I think one is to export as image, that you will not pick up, but there is a generate report document on the top left. So you will go there. You just give a name of the report, your author name, and so on, and then the location. Then which format you want, of course, the PDF, and open after generation. Author Francis, institution LNU. So next, you will pick up everything. So all the three buttons, and then finish, and it should create a PDF with all the diagrams and all the security requirements, and open up the PDF. So as you can see, you will submit submit this PDF on my Moodle, and this PDF is automatically generated. You cannot or do not modify this PDF. So it has this social view, it has this information view, it has this authorization view, and then also this is the most critical part, security requirements. So it is list all the security requirements here. So if this table is empty, that means your model has problems. And then I think these are the violation after the security analysis that were identified. So since I did not solve all the problems, they are there. And then I think, yeah, there is nothing more. So you will submit this PDF on my Moodle. I think there was a question, are we going to summarize these in a final report as well, or is the idea to just use these tools unless it's mentioned after an assignment? We don't have to solve all problems, do we? Okay, so it's better to solve the problems. I mean, you can learn, of course, what is the issue here, but if you cannot, then it's also not a big issue. Okay, I just want to quickly wrap it up here. So that was the scenario. So now the assignment. So that's the most interesting part, I guess, for all of you. So for the assignment, what I will do, I will give you some example systems, and for the example systems, you pick only one system, and then work on that system. So what you will be doing is you will identify stakeholders. So take care of the page limits and make sure that you don't cross those page limits. So identify stakeholders. You will elicit and label 3 functional and 3 non-functional requirements. You will classify the identified requirements using any approach, maybe the faceted approach, maximum 1 page. You will do systematic checklist-based requirements analysis, maximum 1 page also. You will perform a systematic risk analysis or assessment for the requirements. You will perform a systematic validation of the requirements. So all of them is a maximum 1 page. You will propose 1 test case for each of the requirements. So not the test case in detail, like you don't need to mention preconditions, postconditions, input, output, all these things. Just what aspect you want to test for this requirement, just maybe 1 line. So I want to test or for this requirements, I want to test this. That's it. So then pick up 1 functional requirements and do the modeling using UML class diagram. And on that UML class diagram, basically you will define your OCL constraints. So your first deliverable will be the requirements document with all these sub task from RE 1.1 until RE 1.8. And then in the RE 1.9, basically you submit your OCL project as a final zip that I showed today. So your final OCL project will have 3 invariants or 3 OCL constraints. In the second part, you will basically use this STS tool to model the same requirements that you pick in 1.8, and then perform on all the analysis, like security analysis, risk analysis, well-formedness check, and so on, and export your PDF that will include your social information and authorization views plus your security requirements. Some writing guideline or some guidelines on the projects. You need to use Eclipse modeling tools or maybe any other tools if you want to write OCL constraints, or if you want to use other languages for the constraints. But for STS, there is no option, so you need to use this STS tool anyways. There are some specifications for the report, and these specifications are important because there is 10% on the presentation quality and 90% for the content assessment. And make sure that you do not cross 8-page limit for your final requirements document. You should be submitting three deliverables, as I mentioned. So for the first deliverable, you will submit a PDF for the requirements document. For the second deliverable, you will submit the zip project of your OCL, and the third deliverable also another PDF from STS. So you will not be able to basically submit more than 3 files, but make sure when you are submitting your OCL project, you are also submitting the full project instead of just the models. So if you submit if your submission is incomplete, that will not be accepted, and that will be considered as a fail basically. So if you want to change your submissions, you have to go for a retake, not a voluntary opportunity to resubmit. So that was about the assignment, and I hope everything is clear and you enjoyed the lectures. And I will wait a few minutes for your questions if you have, and then if you don't, there is some tutoring sessions on Thursday, so book your slots and ask if you have any questions. So yes, there is also FX. I mean, if you have FX, that's not due to your submission errors, but rather due to your content quality or for your content accuracy. So for the assignment, I think the deadline will be next Friday. So not this Friday, next Friday. So you have more than a week to work on your assignment. The assignment will be released right after this lecture. So in 5-10 minutes. Look at the assignment, and if you have any questions, feel free to book your tutoring slots on my module. Any other questions? I guess it's not. If not, then thank you everyone, and I hope you enjoyed these 3 lectures, although it was long today, but you are free to work on your assignment from today, so it's good for you, I guess. And see you, some of you, on Thursday during the tutoring sessions. Have a nice evening. Bye-bye.